Most silverback confrontations never happen. The rival approaches the boundary. The resident silverback hears the long call. He responds. The two animals move in the same forest for hours, each monitoring the other's position, each producing displays that carry through the trees for a kilometer in every direction. And then one of them leaves. The contest ends without contact. The boundary holds. Nobody dies. But sometimes the rival doesn't leave. Subscribe right now and help us reach 1,000 subscribers. It costs you nothing, and it means everything to this channel. Hit that button, then come back. Because what happens when a silverback fight actually goes all the way is one of the least documented and most important events in the life of a mountain gorilla. And this video is about exactly that. The chest beat that tourists see in managed gorilla tracking visits is the opening sentence of a communication that almost never reaches its final paragraph. It is designed not to. The display that makes the silverback appear larger and louder and more capable than anything else in the forest is designed to deliver a message so clearly that the recipient does not need to test it through contact. The evolutionary logic is sound. An animal that communicates its competitive capability so effectively that rivals withdraw without fighting is an animal that avoids the injuries that direct combat produces, and the avoidance of those injuries is a reproductive advantage that natural selection has refined across millions of years of gorilla evolution into one of the most impressive communication systems in the animal kingdom. The evidence for how well this system works is visible in the survival rates of male gorillas in long-term study populations. The majority of adult male gorillas, including the silverbacks who hold groups and the lone males who range independently through the forest, carry facial scars and body scars that are the legacy of the confrontations they have been in. But the frequency of deaths directly attributable to male combat is low relative to the frequency of the confrontations themselves. The displays work. Most of the time, one animal reads the other's capability from the display and makes the rational decision to leave rather than to test the display against the physical reality it advertises. The confrontations that escalate past the display to direct physical contact are rare. They are also, when they do occur, among the most violent events that the mountain gorilla's forest contains. Understanding what produces them, what they involve when they happen, and what their outcomes mean for the individuals and communities affected is what this video is about. The conditions that predict escalation past the display stage have been identified through decades of behavioral observation at the long-term mountain gorilla research sites in the Virunga volcanoes and at Bwindi impenetrable forest. The most consistent predictor is what researchers call evenly matched capability. Two silverbacks, whose competitive capabilities are genuinely close enough that neither can communicate a clear advantage through display, are silverbacks in a situation where the display cannot resolve the contest, because the display's message is ambiguous. Both animals are producing signals that communicate capability, and neither signal clearly dominates. When the display cannot resolve the contest sometimes has to be resolved through contact. The second major predictor of escalation is what the contest is about. The silverback defending his group of females and juveniles from a rival who is attempting a takeover is in a different situation from the silverback defending a territorial boundary from a neighboring group's boundary testing. The takeover attempt, which involves the potential loss of the group and everything the silverback's reproductive investment in that group represents, raises the stakes of the contest to a level that makes the cost of fighting more acceptable than the cost of losing without fighting. A silverback who retreats from a boundary challenge loses a boundary. A silverback who retreats from a takeover attempt loses his group, his reproductive future, and potentially his life, if the incoming silverback kills his infants to accelerate the female's return to cycling. The asymmetry of the stakes produces asymmetry in the willingness to escalate. The third predictor is the presence of a lone male, a silverback, without a group who is ranging independently through the forest and who is attempting to acquire a group either by separating females from an established group or by challenging the resident silverback directly. The lone male situation is the situation of an animal with no current reproductive success and no group to lose in the contest. His calculus is different from the residents. The cost of fighting is injury, but the cost of not fighting is continued exclusion from reproduction. For the lone male in this situation, the expected benefit of a successful fight exceeds the cost of the injuries the fight might produce, and his willingness to escalate past the display stage reflects this calculation in a way that the resident, who has more to lose, may not match. When the confrontation escalates to contact, the specific sequence of events that follows is determined by the specific physical and behavioral capabilities of the two animals and by the specific terrain and social context of the encounter. The contact phase begins with grappling, the two silverbacks meeting at close range and engaging in the sustained high-force upper body contact that each animal's specific muscle architecture makes possible. The grappling phase involves gripping, pushing, and the application of directional force through the grip in ways that use the specific upper body strength that this channel's Gorilla Strength series documented in detail. The two animals are applying forces that no unarmed human could generate or resist in a physical contest whose outcome depends on the specific combination of mass, strength, technique, and the specific physiological condition of the two individuals at the moment of contact. The bite wounds that characterize serious guerrilla combat are the most clinically significant injuries that the contact produces, and they reflect the specific anatomical weapons that male gorilla morphology has developed through the sexual selection that drives extreme male physical development in this species. The canines of an adult male gorilla are among the largest canines of any living great ape, substantially longer and more robustly built than the canines of females of the same species or of smaller-bodied primates of comparable or larger overall body size. These canines are not feeding adaptations. The gorilla's diet is primarily herbivorous, and the large canines serve no nutritional function. They are weapons, maintained by sexual selection in males, because the males whose canines were larger were the males who won more competitive confrontations and who left more descendants. The canines that a silverback carries in his adult dentition are the cumulative product of millions of years of selection for exactly the function they serve in these rare but decisive confrontations. The bite wounds that the canines produce in serious combat are deep puncture wounds that can penetrate to bone in the facial region, where the thinner bone and the complex anatomy of the skull make the injuries both severe and medically complex. The specific facial scarring that field researchers use as one of the individual identification tools for silverbacks in long-term study populations is the accumulated record of the bites received across a lifetime of competitive confrontations. The most extensive scarring is typically found on the face, which is one of the primary targets in great ape combat, and on the hands and forearms, which are used in defensive gestures that intercept the opponent's biting attacks. Reading the scar pattern of a specific silverback is reading the competitive history of that individual, the confrontations he has been in, the injuries he has sustained, the outcomes that his survival and his current group-holding status reflect. The duration of a serious guerrilla combat, which is one of the variables that determines the severity of the injuries produced, is typically short by human athletic contest standards, but long relative to the forces being applied. Witnesses to serious guerrilla combat, which are rare because the events occur in dense forest with limited visibility, and because habituated study groups are not typically in direct contact with unhabituated rivals, describe the contact as intensely physical and briefly disorienting in its speed and force, with the decisive phase occurring within minutes of the initial contact. The animal that gains the positional advantage in the grappling phase, that achieves the grip on the opponent's body that allows the directional force application, that is the goal of the grappling, is typically the animal that delivers the most significant injury, and the delivery of that injury often determines the outcome of the confrontation. The outcome that most people assume when they think about a silverback fight to the death is the outcome where one animal kills the other through direct physical assault. This outcome occurs, but it is less common than the outcome where one animal sustains injuries severe enough that it dies from those injuries in the hours or days following the confrontation, or the outcome where one animal flees the confrontation and subsequently dies from the cumulative effects of the injuries sustained. The direct killing of a defeated silverback by the victor is documented in the research literature, But it is not the modal outcome of even the most serious confrontations. The more common outcome is the incapacitation of one animal, either through the sustained force of the grappling or through the specific injuries of the bite wounds, followed by that animal's retreat and the subsequent deterioration of its condition from the injuries it carries. The aftermath of a serious confrontation for the winning silverback is not simply the acquisition of the prize that the contest was about. Whether that prize was the group or the territory, or the exclusion of the rival from the competitive space, it is also the management of the injuries that the winner has sustained, because the fight that the winner won still cost the winner something. The bite wounds on the winner's body are wounds that require healing, that carry infection risk in the forest environment, and that temporarily reduce the physical condition that future competitive confrontations will require. The winner of a serious guerrilla combat is not unmarked by the combat. He is a winner who carries the evidence of the contest in his body, alongside the scar tissue that the previous contests have left, building the individual record that field researchers read in the identification photographs they take of each individual at every encounter. The females and juveniles of the group that was the subject of a takeover confrontation are not passive observers of the contest's outcome. Their responses to the confrontation and to the outcome are part of what determines the stability of the group following the contest. The females who have long established relationships with the resident silverback may resist the transition to a new dominant male through behavioral resistance, including remaining near the defeated male if he survives, refusing the approaches of the new dominant, and in some cases, attempting to leave the group entirely rather than accept the change in leadership. The juveniles of the group, whose vulnerability to infanticide by the incoming male is one of the stakes of the confrontation, may be defended by their mothers, and sometimes by the defeated male if he survives. The social complexity of the group's response to a takeover confrontation is as interesting and as consequential as the physical confrontation itself. The infanticide that typically follows a successful male takeover is one of the most disturbing behaviors in the guerrilla behavioral repertoire, and it is one that illuminates the specific reproductive logic that the entire confrontation sequence serves. When a new silverback gains control of a group, the nursing infants and young juveniles of the group are the offspring of the previous silverback, and their continued presence in the group delays the sexual cycling of their mothers, who will not return to reproductive availability until their infants are weaned. The new silverback that kills these infants eliminates competitors from the next generation and simultaneously accelerates the availability of their mothers for reproduction, producing offspring of the new silverback's own genes on the earlier timeline that the infant deaths make possible. This behavior is not sadism or cruelty in any meaningful sense. It is the expression of a specific reproductive strategy whose logic is the same cold arithmetic of natural selection that underlies every behavior in the gorilla's repertoire. It is maintained in the population because the males who practiced it were the males who reproduced more, and their descendants carry the same behavioral tendency into the next generation. The specific case studies from the Virunga Volcanoes research program that have documented serious silverback confrontations provide the most detailed available accounts of what these events look like in the field. The research teams at the Karisoki Research Center, founded by Dian Fossey in 1967, and at the subsequent research programs that have continued in the Virunga region, have documented multiple cases of serious intergroup conflict across decades of monitoring. The accounts in the research literature describe the acoustic experience of the forest during a serious confrontation, the long calls and the displays, and the sounds of grappling that carry through the vegetation and alert the research team that something significant is happening, followed by the visual evidence that the aftermath reveals: the injured animals, the disturbed vegetation, the changed composition of the groups involved. The research records that these cases have produced are among the most valuable behavioral data on guerrilla combat available, and they form the empirical foundation of everything this video has described. The conservation dimension of serious guerrilla combat is worth noting because in a species whose total population is measured in the thousands rather than the millions, the deaths of individual silverbacks in combat have demographic consequences that the same event in a species with abundant populations would not produce. The mountain gorilla population, which has grown from below 600 individuals in the early 2000s to over 1,000 today through intensive conservation intervention, is still small enough that the loss of a reproductive silverback to combat represents a meaningful reduction in the genetic diversity and the reproductive potential of the population. Conservation programs that monitor habituated groups are therefore interested in the outcomes of serious confrontations, not only for the behavioral data they provide, but for the direct demographic consequences they may have. The silverback that survives a serious confrontation, whether as winner or as wounded loser, carries the experience of the confrontation forward in the behavioral profile that subsequent research encounters reveal. The research literature on individual behavioral variation among silverbacks documents differences in the willingness to engage in escalated confrontations, the specific tactics used in the display and the contact phases of competitive interactions, and the specific social relationships with other males that shape the competitive landscape each silverback navigates. These individual differences are the product of the specific history of each animal, the confrontations it has won and lost, the injuries it has sustained, the outcomes that its competitive career has produced, and the current physical condition that this history has left it in. The silverback is not simply a representative of the species in competitive behavior. It is a specific individual with a specific competitive history, navigating a specific social landscape with the specific resources that its history has left it. Tonight, in the mountain forest, the silverbacks of the Virunga are in their night nests. The confrontations of the day resolved by the outcomes that the displays and rarely the contact produced. The scars they carry are the record of the contests that brought them to where they are. The groups they hold, or the solitary ranging they do in the absence of a group, are the current expression of that competitive record. And the long call that will announce the morning tomorrow is the next sentence in the communication that the confrontation this video described is part of. The continuous, specific, high-stakes conversation between silverbacks about who has what and who can hold it. Sleep well. The acoustic environment of the mountain gorilla forest, in the hours surrounding a serious confrontation, is one that experienced researchers describe as distinctly different from the normal acoustic texture of the mountain forest. The long calls that the two competing silverbacks produce carry information that every other gorilla in the area is reading and responding to. The females and juveniles of both groups move toward or away from specific positions in response to the acoustic signals. The adult males of any nearby group monitor the confrontation through its acoustic dimensions, assessing the competitive dynamics of the two combatants and adjusting their own behavior accordingly. The forest is not a passive backdrop to the confrontation. It is an active social environment that the confrontation is occurring within, and that is shaped by the confrontation's acoustic output in ways that the research teams have documented by tracking the movements of multiple groups simultaneously during periods of intergroup tension. The physical condition that predicts a silverback's competitive success in serious confrontations is more complex than simple body mass. Though body mass is correlated with competitive success in the research data, the specific muscle condition, the experience of previous confrontations, the current state of any injuries from previous encounters, and the specific behavioral repertoire of the individual, including the effectiveness of his display and the specific tactical choices he makes in the contact phase, all contribute to the competitive outcome in ways that make the prediction of any specific confrontation's result genuinely uncertain. The research literature on gorilla competitive outcomes has found that while larger males win more confrontations on average, the distribution of outcomes across size comparisons shows enough variance that size alone does not predict the result with high reliability. The animal with a specific tactical advantage, or with the greater urgency that the higher stakes of its situation create, sometimes wins against a larger and otherwise more capable opponent. The role of coalition support in serious silverback confrontations is less prominent in gorillas than in chimpanzees, where the coalition is the primary competitive weapon, as described in this channel's chimpanzee series. The gorilla's competitive system is primarily organized around individual male competition rather than coalition-based competition, reflecting the different social architecture of the two species. A silverback group typically contains only one fully adult male, and the competitive confrontations are therefore primarily one-on-one rather than coalition-based. However, the presence of other males in the area, including subadult males who may be affiliated with one or the other of the competing silverbacks, can influence the dynamics of a confrontation by providing additional display support or by creating a numerical context that affects the competitive assessment. The research on multi-male gorilla groups, which occur primarily in the eastern gorilla subspecies, has documented cases where the presence of multiple males in the same group creates a more complex competitive environment that shares some features with the coalition-based competitive system of chimpanzees. The specific terrain of the Virunga volcanoes, where the mountain gorilla research has been most intensive and where the most detailed accounts of serious silverback confrontations have been documented, shapes the specific dynamics of the confrontations in ways that would be different in the lowland forest habitats of the western gorilla subspecies. The dense, steep vegetation of the high-altitude Virunga forest creates a confrontation environment with limited visibility, where the acoustic signals of the confrontation carry information that the visual signals cannot, and where the specific terrain features, slopes, ridgelines, dense bamboo stands, create tactical advantages and disadvantages that the competitors navigate in ways that reflect their specific knowledge of the local landscape. The silverback, who knows his own range better than the intruder does, has a specific informational advantage in the confrontation that the intruder's potential size advantage does not fully compensate for. The research documentation of the aftermath of serious silverback confrontations has revealed the specific ways in which the social organization of the gorilla community is reshaped by the outcome of the contest. When a takeover attempt succeeds, the group's composition changes in the specific ways that the takeover sequence produces. Females may leave the group rather than accept the new male, reducing the group's size and reproductive potential. The infants and young juveniles whose fate the infanticide literature documents are the most vulnerable members of the community in the transition period, and the specific protection strategies that their mothers employ are one of the most intensively studied aspects of the post-takeover social dynamics. When a takeover attempt fails, the defeated challenger's subsequent behavior, whether he ranges alone or attempts to acquire females from other groups or eventually finds a path back into a social group, is determined by the specific injuries he sustained and the specific competitive landscape that the failed attempt has left him in. The long-term demographic consequences of serious silverback confrontations for the mountain gorilla population, which is the scale at which the conservation program is most concerned with the outcomes, have been tracked through the continuous monitoring of the habituated groups in the Virunga region. The specific groups that have experienced takeover confrontations show predictable patterns of demographic change in the years following the confrontation. Reduced juvenile survival in the transition period, reorganization of the female composition of the group as some females leave and others are acquired, and in some cases, the temporary destabilization of the group's ranging patterns as the new social organization establishes itself. The research teams that have monitored specific groups through multiple leadership transitions over decades have the most complete picture of these demographic dynamics available, and their data is one of the primary empirical resources for understanding the population-level consequences of the competitive system that this video has described. The comparison between what happens when a silverback confrontation goes to its ultimate conclusion and what happens in the vast majority of confrontations that do not go that far illuminates the specific function of the display system in a new way. The display works not because it is an arbitrary signal, not because it is a bluff that the recipient simply decides to accept. It works because it accurately communicates a capability that the confrontations that go all the way demonstrate is real. The silverback that produces the most impressive display, the fastest charge, the loudest chest beat, the most forceful ground slapping, is generally the silverback that would win the physical confrontation if it occurred. The display is an honest signal in the evolutionary biology sense. It is correlated with the underlying capability that it advertises, and the system of honest signaling that the competitive confrontation history has shaped is what makes the display effective as a conflict resolution mechanism. The fights that go all the way are, among other things, the calibration events that keep the honest signal system honest. The specific role of the female gorilla in the competitive dynamics between silverbacks is more active than the passive observer role that the dramatic focus on male combat might suggest. Female gorillas in groups where a challenge is occurring make specific behavioral choices that reflect their own assessment of the competitive situation and their own reproductive interests. A female whose current silverback is clearly inferior to the challenger may facilitate the takeover by moving toward the challenger rather than away from him, effectively reducing the resident's group size and his competitive advantage in the contest. A female with nursing infants has the strongest incentive to support the resident because the risk of infanticide from a new male is the most direct threat to her current reproductive investment. The specific choices that individual females make during competitive confrontations are therefore not random or irrelevant to the outcome. They are part of the competitive dynamics, expressing the female's own reproductive interests in the specific ways that the gorilla social system allows. The evolutionary history of the gorilla combat system, which connects to the broader evolutionary history of sexual dimorphism and male competitive behavior, across the great apes and across the primates more generally, illuminates what the specific form of gorilla competition reveals about the specific ecological and social conditions that produced it. The extreme sexual dimorphism of the gorilla, where the silverback may weigh twice the body weight of an adult female, is among the most pronounced in the primate order, and the magnitude of this dimorphism is generally interpreted by evolutionary biologists as a marker of intense male-male competition. The greater the dimorphism, the greater the intensity of the competition that's selected for the extreme male morphology, because the development and maintenance of the extreme male body is energetically costly and would not be maintained by evolution unless the competitive advantage it provides is sufficiently large to outweigh the cost. The gorilla's extreme dimorphism is evidence that gorilla male competition has been intense across the evolutionary history of the species, and the confrontations this video has described are the current expression of that historical intensity. The specific case of Digit, the young silverback whose death at the hands of poachers in 1977 galvanized international attention to the mountain gorilla's plight, and whose fate is inseparable from the story of Dian Fossey's conservation work in the Virunga, is relevant to the combat question in a specific way. Digit was not killed in a confrontation with another silverback. He was killed defending his group from poachers, sustaining multiple spear and machete wounds, while the rest of the group escaped. The behavioral profile that Digit's death revealed, the willingness of an adult male gorilla to place himself between a threat and his group at the cost of his own life, is behavior that the competitive confrontation system and the group defense system share. The silverback that fights a rival for his group and the silverback that fights poachers for his group are expressing the same protective response to the same category of threat, in the specific form that the specific threat requires. Digit's death made this visible in a way that no amount of behavioral description could. The veterinary data on gorilla combat injuries, which has been collected through the veterinary programs that monitor the health of habituated gorilla groups in the Virunga and Bwindi, provides a clinical picture of the injuries that serious confrontations produce that complements the behavioral observation data. The veterinary teams that treat injured gorillas in the field, using dart guns to anesthetize the injured animal and conducting the treatment as quickly as possible to minimize the disruption to the group, have documented the specific injury profiles of the animals they have treated in ways that illuminate the mechanics of gorilla combat from the clinical perspective. The bite wounds that the canines produce are the injuries that most commonly require treatment, followed by the blunt force injuries of the grappling phase. The infection management of bite wounds is a particular challenge in the field veterinary context because the mountain forest environment is not a sterile one, and the bacterial load of bite wounds in this environment is high. The veterinary interventions that have allowed specific animals to survive injuries that would otherwise have been fatal are part of the conservation success story that has produced the mountain gorilla population growth of recent decades. The social memory that gorilla communities carry of previous confrontations is one of the dimensions of gorilla competitive behavior that the behavioral research has illuminated through the long-term tracking of specific individuals and specific groups. The silverbacks in a specific region have histories with each other that extend across years of boundary encounters, displays, and in some cases contact confrontations. And the specific history of each dyad shapes the current competitive dynamic between those two individuals. A silverback who defeated a specific rival in a contact confrontation 3 years ago and who encounters that rival again at the boundary today is in a different situation from a silverback encountering an unknown rival for the first time. The specific competitive history provides information that is relevant to the current competitive assessment, and the behavioral evidence from long-term research populations suggests that gorillas do adjust their competitive behavior based on the specific history they have with specific individuals. The competitive system is not simply about current capability. It is about the history of demonstrated capability in specific dyadic relationships. The answer to the question this video posed, what would happen if you watched a silverback fight to the death, is an answer that is specific rather than dramatic. What you would witness is the activation of a competitive system that the display normally resolves without contact, operating in the rare conditions where the display cannot resolve the contest. You would witness two of the most physically capable animals in the primate world applying that capability in the specific directional force of the grappling and the specific targeted force of the bite. You would witness the acoustic and visual intensity of a confrontation whose specific dynamics, the terrain, the social context, the individual histories of the two animals, are what determine the outcome rather than any simple size comparison. And you would witness the aftermath, the injured animals, the changed group compositions, the reshaped social landscape of the community that the confrontation leaves behind. The confrontation is real, its rarity is real, and the significance of what it is for the gorilla community, and for the understanding of the competitive system that evolution has built in this species, is real in the specific and grounded way that the research has documented. Sleep well. The specific behavioral signals that field researchers have learned to read as indicators of elevated intergroup tension and therefore as predictors of the confrontations that may follow are part of the practical knowledge base that the long-term research programs have built across decades of observation. The silverback, whose patrol behavior at the group's range boundaries increases in frequency and whose display rate is elevated relative to his baseline, the adult males of the group who are showing increased vigilance and whose foraging efficiency is reduced by the attention they are directing toward the periphery of the range. The changes in the group's ranging patterns that shift its activity toward the core rather than the margins of its territory. All of these behavioral signals are the early chapters of a story that may end in the confrontation this video has described, or may end with the resolution of the competitive tension through the display system, and without contact. The researchers who know the specific individuals and the specific current social landscape well enough to read these signals are the researchers who are most likely to be present when the confrontation reaches its most significant moments. The specific post-traumatic stress-like behavioral changes that have been documented in gorillas who have survived serious confrontations are part of what the veterinary and behavioral monitoring of rehabilitating animals has revealed about the psychological as well as the physical consequences of these events. Animals recovering from serious injuries sustained in confrontations show changes in their social behavior, their ranging patterns, and their competitive display behavior that are consistent with the elevated vigilance and reduced social engagement that traumatic experience produces in other primates, including humans. The specific duration and the specific trajectory of recovery from these behavioral changes varies with the severity of the injury and with the social resources available to the recovering animal, including the support of affiliated females and the availability of social bonding behaviors that reduce the physiological stress response. The psychological dimension of the confrontation's consequences is less studied than the physical dimension, partly because it is harder to document with the behavioral tools available in field settings, but it is a real dimension of what the confrontation leaves behind. The research teams that have monitored mountain gorilla groups through serious confrontations describe the experience of being present during the acoustic phase of a confrontation, hearing the long calls and the display percussion and the vocalizations of the grappling if the contact phase occurs, with a specific quality that the routine behavioral observation does not produce. The specific intensity of the sound environment during a serious confrontation, the volume and the urgency of the vocalizations, the sounds of vegetation being destroyed in the display, and the contact phases, and the behavioral responses of every other gorilla in the area to the acoustic information the confrontation is generating, creates a sensory environment whose impact on the observers present is documented in their accounts with a vividness that reflects the genuine quality of the experience. Being present in the forest when a serious silverback confrontation is occurring, even at a distance that limits visual observation, is an experience that the researchers who have had it describe as one of the most distinctive of their fieldwork careers. The conservation implications of the competitive system this video has described extend beyond the immediate demographic consequences of specific confrontations to the broader question of how the mountain gorilla's social and competitive system interacts with the conservation management practices that have produced the population growth of recent decades. The intensive veterinary intervention program, which treats injured animals and reduces the mortality from combat injuries that would otherwise occur, is one of the most direct interventions in the competitive system that the conservation program provides. The decisions about which animals to treat, when to intervene, and how aggressively to manage the injuries that the confrontations produce are decisions that balance the welfare of individual animals against the naturalness of the competitive system that the population's genetic diversity and social organization depend on. The management of these decisions across the decades of the mountain gorilla conservation program has produced a body of practice and a body of knowledge about the interactions between the competitive system and the conservation intervention that is itself one of the most valuable data sets in applied conservation biology. The silverback in the mountain forest has been doing what this video has described for longer than modern humans have existed. The competitive system that produces the confrontations, the display, the contact combat, the post-confrontation reorganization of the social landscape is a system that evolution has refined across millions of years of gorilla history in environments that had no human observers and no conservation programs and no veterinary teams. The specific form the system takes in the habituated study populations of the Virunga and Bwindi is the form it takes in the presence of the research and conservation program that has changed the mountain gorilla's situation in specific ways while leaving the essential competitive dynamics of the species intact. What the research has produced across the decades of monitoring that the conservation program has enabled is the most detailed account available of how this system works, what it produces, and what it means for the individual animals and the communities it shapes. That account is what this video has tried to convey. Sleep well. The specific research on the relationship between a silverback's display quality and his actual competitive capability, which addresses the evolutionary biology question of whether the gorilla's signal system is an honest one, has been conducted through the analysis of display acoustic properties and their correlation with the physical measures of competitive capability that are available for the habituated study populations. The chest beat's acoustic properties, including its amplitude, its pulse rate, and the specific frequency content that reflects the size and the resonance characteristics of the chest cavity, have been analyzed in relation to the body size and the competitive success record of the individual males who produced them. The results are consistent with the honest signal hypothesis. The acoustic properties of the chest beat are correlated with body size in ways that make the display a reliable source of information about the displayer's competitive capability, at least at the level of size. The finer-grained competitive qualities, the specific tactics and the specific experience that influence outcomes in contact confrontations are less clearly encoded in the display, which is why the display cannot always resolve contests between animals whose capabilities are genuinely close. the social behavior of subadult males in groups that experience competitive pressure from outside, which is the developmental context in which the next generation of silverbacks is formed, reveals how the competitive system is transmitted across generations. The subadult male who observes his father, or the group's current silverback, conducting the display, and, in rare cases, the contact confrontation, is accumulating behavioral experience that will shape his own competitive behavior when he reaches sexual maturity and begins his own competitive career. The specific display behaviors that the subadult practices in the context of within-group play and social interaction are early iterations of the behaviors that he will deploy as an adult in the competitive confrontations that this video has described. The competitive system is not simply genetically transmitted, it is also socially learned, in the specific way that behavioral observation and practice across the extended juvenile period of great ape development allows complex behavioral repertoires to be acquired and refined. The rarity of the events this video described, which is both a product of the effectiveness of the display system and a function of the specific ecological and demographic conditions of the mountain gorilla population, means that the research literature on serious silverback confrontations is based on a relatively small number of directly observed events. The data that exists is precious precisely because of its rarity, and the researchers who have documented these events have done so with the specific attention and the specific care that rare and significant behavioral events receive in a research program organized around the long-term monitoring of specific individuals. What the research has produced from this small number of events documented across decades of intensive monitoring is a picture of the confrontation system that is specific enough to support the conclusions this video has drawn, while acknowledging that the small sample size of direct observations means that the picture will be refined by future events and future documentation. The confrontations will continue to occur. The research programs that can document them will continue to monitor the populations, and the understanding of what the confrontations are and what they produce will continue to deepen with each additional data point that the rare events provide. Sleep well. The specific ecology of the mountain gorilla's habitat, which shapes both the distribution of the competitive confrontations across the landscape and the specific terrain in which they occur, has been studied in relation to the competitive system through the spatial analysis of intergroup encounters. Groups that share longer boundary lengths with neighboring groups have higher rates of intergroup encounters, which is expected, but the rate at which these encounters escalate past vocal exchange and display to contact confrontation is also influenced by the specific resource value of the disputed boundary area. Boundaries adjacent to productive foraging areas, which both groups have competitive motivation to access, produce higher rates of escalated confrontations than boundaries adjacent to less productive areas. The specific distribution of food resources in the mountain gorilla landscape is therefore not only a foraging variable, but a competitive variable, shaping the geography of the confrontation system in ways that the behavioral data reveals when the ranging data and the intergroup encounter data are analyzed together. The gorilla combat system that this video has described is, in the end, a system built on a foundation of accurate information exchange. The display is designed to provide accurate information about competitive capability. The contact confrontation, when the display cannot provide a clear answer, provides the definitive information that the contest requires, and the outcome of the confrontation, which reshapes the competitive landscape of the community and the reproductive futures of the individuals involved, is the information that the next generation of competitive interactions will be built on. The system works because the information it exchanges is accurate, because the animals that produce it and the animals that receive it have been shaped by evolution to produce and read accurate information, and because the competitive outcomes that result from the information exchange are the outcomes that the evolutionary history of the species has produced as the stable solution to the specific competitive challenges of gorilla social life. What this video has tried to describe is not simply violence. It is information in the specific biological sense that evolution uses. Sleep well. The mountain gorillas that carry the scars of past confrontations on their faces and their hands are the living archives of the competitive system this video has described. Each scar is a data point. Each data point is part of the competitive history of a specific individual in a specific community, navigating a specific competitive landscape over the years of its adult life. The researchers who read those scars in the identification photographs they take at each encounter with each individual are reading the competitive history of the gorilla community in the same way that a geologist reads the strata of a rock face, layer by layer. Each layer the record of a specific event in a specific moment, accumulated into the total record of a life lived in the specific conditions that the mountain forest and the competitive social world of the mountain gorilla provide. What the record shows, for each individual and across the population, is what this video has tried to convey: a competitive system of extraordinary sophistication, operating through honest signal exchange and decisive physical contest, producing the social landscape that the mountain gorilla community inhabits and that the conservation program is working to preserve. Sleep well. The specific questions that remain most open in the research on gorilla combat, including the precise neural and hormonal mechanisms that produce the escalation from display to contact, the specific individual level variables that predict which animals will escalate when the display is ambiguous, and the long-term consequences of combat experience on an individual's subsequent competitive behavior, are questions that the ongoing research programs are positioned to address as the longitudinal datasets they are building accumulate additional years of data. Each additional year of monitoring a specific individual across a specific competitive career adds data points to the picture of the competitive system that the existing research has produced. And the picture that will exist in another decade will be more detailed and more precise than the picture this video has drawn. The confrontations will continue, the research will continue, and the understanding of what the confrontations are and what they mean for the gorillas who experience them, and the communities that are shaped by them, will continue to deepen. That is what the research is for. Sleep well. The specific contribution of the mountain gorilla combat research to the broader understanding of great ape social evolution is one that connects the gorilla system to the chimpanzee system and the bonobo system described in this channel's other series, illuminating what is shared across the great apes in competitive behavior and what is specific to each species' particular solution to the competitive challenges of its ecological and social world. The chimpanzee's coalition-based competitive system, in which the political alliance of males is the primary competitive weapon, produces a different form of violence and a different form of social organization from the gorilla's individual combat system, in which the single dominant male's display and fighting capability is the primary competitive mechanism. The bonobo's female coalition system, in which female alliance rather than male competition is the organizing principle of the social hierarchy, is a third solution to the same fundamental competitive challenge. All three solutions are expressions of the great ape cognitive and social architecture, operating in different ecological contexts with different constraints and different opportunities, and the comparison between them illuminates each individual system by showing what the alternatives look like and why each species ended up where it did. The gorilla fight to the death is one expression of what great ape competition can produce. Understanding it in context means understanding the full range of expressions that the same underlying potential has produced across the species that share our evolutionary heritage. The forest is quiet now. The confrontation that this video described, whether it resolved through display or through contact, has resolved. The gorillas are in their nests. The silverback, whose competitive career the confrontation was part of, is resting with the physical evidence of the contest on his body and the social evidence of the outcome in the community around him. Tomorrow the ranging will resume, the long calls will announce the morning. The foraging will take up the hours that the competitive encounters do not. And at some point in the future, the next boundary encounter will occur. The next display will be produced. The next assessment of the competitive landscape will be made by the animals involved. The system continues. It has been continuing for longer than our species has existed to observe it, and it will continue in the specific forests that the conservation program is working to protect, for as long as the gorilla communities that express it remain. Sleep well. There is a moment that every researcher who has spent time with habituated mountain gorillas describes differently, but that all describe as the same. A silverback sits 15 meters away. He is not doing anything dramatic. He is resting or eating slowly, or watching the juveniles play nearby. And he turns and looks directly at you, not through you, at you, with the specific quality of attention that the people who have experienced it reach for language to convey and find language inadequate for. Something specific is happening behind those eyes. Something is assessing you, filing you, comparing you against a record of prior encounters and prior individuals. Something that has been alive in this forest for 30 years is thinking something about you, and you cannot know what it is. This video is about what 60 years of research has revealed about what that something is. Help us reach 1,000 subscribers. Hit the button right now. It takes 2 seconds, it costs you nothing, and it keeps this channel going. Subscribe now, then stay with us, because what gorilla cognition research has actually found is stranger and more impressive than anything the popular account of these animals has managed to convey. The question of what a gorilla is thinking has occupied researchers since Jane Goodall and Dian Fossey made the first sustained behavioral observations of wild great apes in the 1960s and established that the question was worth taking seriously. Before the field research of that era, the prevailing assumption was that non-human primates were primarily stimulus-response machines whose behavioral complexity could be adequately explained by conditioning and learning without attributing to them anything resembling the cognitive processes that humans engage in. The field research destroyed that assumption in stages, each stage requiring a specific piece of evidence that the previous assumption could not accommodate. Across the 60 years that followed, the gorilla's cognitive profile is different from the chimpanzees in specific ways that reflect the different social and ecological demands of each species' life, and understanding the gorilla's intelligence requires setting aside the chimpanzee as the implicit standard against which all great ape cognition is measured. The chimpanzee's intelligence is social intelligence, shaped by the specific demands of navigating a politically complex community of dozens of individuals in constant social contact. The gorilla's intelligence is different in emphasis without being less sophisticated. It is the intelligence of an animal that manages a smaller, more stable social group, that has fewer but deeper long-term social relationships, and that navigates a competitive landscape organized around individual male competition rather than coalition politics. Both are genuine forms of intelligence shaped by different evolutionary pressures expressed in different behavioral profiles. The memory research on gorillas, which has been conducted primarily in captive settings where the controlled conditions required for memory testing are possible, has produced results that illuminate the gorilla's cognitive capabilities in ways that the field observation data alone cannot. The long-term memory of captive gorillas for specific individuals they have not encountered in years, including the recognition of human caretakers who left the facility and returned years later, is documented in anecdotal accounts from multiple zoo and sanctuary facilities that are consistent enough to constitute a pattern. The specific experimental research on gorilla object permanence, the understanding that objects continue to exist when they are no longer directly visible, has found that gorillas understand object permanence at a level comparable to human infants in the second year of life, which is substantially more sophisticated than the object permanence understanding of less cognitively complex species. The mirror self-recognition research on gorillas has produced results that are more complicated than the equivalent research on chimpanzees, bonobos, and orangutans, all of which pass the mirror test reliably. Gorillas as a species show inconsistent performance on the mirror self-recognition task, with some individuals demonstrating clear self-recognition behavior and others showing only social responses to the mirror image, treating it as another gorilla rather than as a reflection of themselves. The inconsistency has been interpreted in multiple ways. Some researchers have argued that the gorilla's avoidance of direct eye contact in social contexts which is a submission signal in gorilla communication, makes the mirror test specifically difficult for gorillas because the mirror image maintains eye contact in a way that is socially aversive. Others have suggested that the inconsistency reflects genuine individual variation in self-awareness within the species. The case of Coco, the gorilla who learned American Sign Language and who passed the mirror test while demonstrating other indicators of self-awareness in her communication, has been used to argue that the species-level inconsistency reflects a task-specific limitation rather than an absence of the underlying self-awareness that the task is designed to measure. The Coco research, conducted by Francine Patterson beginning in 1972, is the most widely known example of great ape language research involving a gorilla, and it occupies a complicated position in the scientific literature that is worth addressing directly. Coco learned over 1,000 signs of American Sign Language, and her performance on the sign language tasks she was given produced a body of data that has been cited in both popular and scientific contexts as evidence of gorilla linguistic capability. The complications arise from the specific methodological limitations of the Coco research, which was less rigorously controlled than the parallel research on chimpanzees and bonobos conducted by the Gardners, Terrace, and Savage Rumbaugh. The specific concerns include the possibility of inadvertent cueing by the human interlocutors, the difficulty of distinguishing genuine novel sign combinations from prompted responses in the context of the research, and the absence of the kind of controlled replication that the scientific community requires to treat the findings as established. The Coco research produced genuine data of genuine interest. It also produced claims that outran the data in ways that the scientific community has been appropriately cautious about accepting at face value. What is less disputed about Coco is the behavioral evidence of her emotional and social sophistication that the long-term research relationship with Patterson produced, independent of the specific claims about linguistic competence. Coco's responses to the deaths of individuals she was close to, including the death of her companion cat and the death of Robin Williams, who had visited and interacted with her, were documented in ways that the behavioral science of emotion in non-human primates has recognized as consistent with the hypothesis that gorillas experience something functionally analogous to grief. The specific behavioral responses, the reduced activity, the specific vocalizations, the altered social behavior in the days following the loss, are responses that the gorilla behavioral literature from wild populations corroborates in its documentation of how gorilla communities respond to the deaths of group members. The gorilla's emotional life, which the Coco data and the wild population data together illuminate from different angles, is one of the most actively debated dimensions of gorilla cognition. The debate is not about whether gorillas have emotional states in the functional sense, that they have internal states that influence behavior in the way that emotions influence human behavior. The behavioral evidence for that is overwhelming. The debate is about whether gorillas have emotional states in the subjective sense, whether there is something it is like to be a gorilla experiencing the loss of a companion, whether the functional state involves a subjective quality that the human experience of grief shares. This question is not resolvable with the tools currently available, and the research community approaches it with appropriate caution. What is clear is that the gorilla's behavioral responses to emotional events are specific, consistent, and organized in ways that the simple stimulus response account cannot adequately explain. The planning ahead capability of gorillas, which has been studied both in captive experimental settings and in the behavioral data from wild populations, produces results that illuminate the gorilla's future-oriented cognition in ways that connect to the broader research on planning in great apes. The gorilla that builds a sleeping nest each evening, selecting and bending the appropriate vegetation in the specific location where the group will rest, is doing something that requires a representation of a future state, the resting state that will occur in this location that is not yet real at the time the nest is constructed. The nest construction is not simply a conditioned behavior. It involves decisions about material selection and location that reflect the gorilla's assessment of the specific requirements of the future rest period and these decisions vary with the specific conditions of the terrain and the vegetation available. The behavioral flexibility of nest construction across different environments and different vegetation types is evidence that the gorilla is not following a fixed behavioral program, but is making decisions based on the specific conditions of the current situation in relation to a representation of the future state the nest will serve. The social relationships that gorillas maintain within their groups, which have been studied through the behavioral observation data at long-term research sites and through the hormonal data that non-invasive sampling allows, are relationships of genuine complexity and genuine consequence for the individuals involved. The specific affiliative behaviors that gorillas engage in, including the grooming that has been documented at lower rates in gorillas than in chimpanzees, but that plays the same social bonding function in the groups where it occurs. The proximity maintenance between specific individuals that reflects the specific bonds between them, and the specific conflict resolution behaviors that reduce the tension following competitive interactions within the group, are behaviors that require a model of the other individuals in the group and of the specific social relationships between them. The gorilla navigating the social dynamics of its group is a gorilla running a continuous social model of the individuals around it and the relationships between them, and the sophistication of that model is part of what the individual recognition and the long-term relationship maintenance that the research documents requires. The specific research on gorilla problem-solving capability, which has been conducted in captive settings using apparatus-based tasks that require the manipulation of objects to obtain food rewards, has found that gorillas are capable of multi-step problem-solving, of tool use in some contexts, and of the specific reasoning about physical causation that requires understanding the relationship between an action and its effect on the physical world. The gorilla's spontaneous tool use in the wild, which is less elaborated than the chimpanzee's extensive tool culture, includes the use of sticks as walking supports in deep water and the use of vegetation as cushioning on uncomfortable substrates. These tool uses are less sophisticated than the termite fishing and nut cracking of chimpanzees, but they demonstrate that the gorilla's cognitive architecture supports the insight into physical causation that tool use requires, and that the lower frequency of wild gorilla tool use reflects ecological conditions rather than cognitive limitations. The individual variation in cognitive style and behavioral personality that has been documented in gorilla populations, including both wild and captive individuals, is one of the most interesting findings in the gorilla cognition literature for what it reveals about the nature of the cognitive system involved. The research that has applied personality rating instruments to gorilla populations, using behavioral observation to score individuals on dimensions analogous to the Big Five personality dimensions used in human personality research, has found consistent individual differences in dominance, sociability, curiosity, and emotional reactivity that are stable across time, and that predict specific behavioral outcomes in the contexts where those personality dimensions are most relevant. The gorilla that scores high on curiosity explores novel objects and situations more readily than the gorilla that scores low. The gorilla that scores high on sociability maintains more frequent affiliative contacts with group members and spends more time in proximity to others. These individual differences are not noise in the data. They are real, stable properties of specific individuals, and they reflect the specific cognitive and behavioral architecture of a species whose individual variation is genuine and consequential. The research on gorilla social learning, which examines how behavioral innovations spread through gorilla groups and populations, has produced findings that illuminate the cultural transmission mechanism in this species. Gorillas in wild populations show behavioral traditions that differ between groups in ways that reflect the specific history of behavioral innovation and transmission in each group, rather than differences in the ecology or the genetic background of the populations. The specific behaviors used in social interactions, the specific ways of acquiring and processing specific food types, and in captive populations, the specific problem-solving strategies applied to apparatus tasks that have been solved by one individual show transmission patterns consistent with social learning from specific demonstrators. The gorilla is not simply learning from the environment, It is learning from other gorillas, attending to what specific individuals do and incorporating what it observes into its own behavioral repertoire. The question that the silverback's gaze posed at the beginning of this video, what is happening behind those eyes, has been approached across 60 years of research from multiple directions and with multiple methodologies, and the answer that the research has produced is more specific and more impressive than the simple claim that gorillas are intelligent would suggest. What is happening is a cognitive system running the specific computations that the gorilla's life requires: the social model of the group and its individuals, the spatial model of the familiar landscape and its resources, the temporal model of the seasonal patterns that the group's food supply depends on, the competitive model of the other silverbacks in the surrounding area and their current status, and the specific assessment of the current situation, including the observer who is sitting 15 meters away and who is being evaluated with the same cognitive attention that the gorilla directs at anything else in its environment that requires evaluation. The eyes that are looking at you are not reflecting a simple mind. They are reflecting a complex one, shaped by millions of years of evolution in the specific social and ecological world of the mountain gorilla, and doing what that mind does: paying attention, assessing, filing, deciding. Sleep well. The specific research on gorilla numerical cognition, which has been conducted in captive settings, using the same types of quantity discrimination tasks that have been applied to chimpanzees and other primates, has found that gorillas can distinguish between quantities in a range of presentation formats, and that their performance on these tasks is consistent with a genuine understanding of numerical quantity rather than simply a learned discrimination between specific trained stimuli. The gorilla's numerical performance is generally comparable to the chimpanzees on the tasks where both species have been tested, which is itself an informative finding given the substantial differences in the social and ecological context of the two species' lives. The cognitive capability for numerical quantity understanding appears to be a shared great ape trait rather than a specific chimpanzee advantage, and the specific social context in which it is most obviously adaptive, the tracking of the number of allies and rivals in competitive contexts, is a context that gorillas navigate with the same cognitive tools that chimpanzees bring to the same problem. The research on gorilla causal reasoning, which examines whether gorillas understand causal relationships between events or simply learn associations between stimuli and outcomes, has produced findings that illuminate the specific nature of the gorilla's physical world understanding. The experimental paradigm that has been most productive for this question involves presenting gorillas with apparatus tasks where the solution requires understanding a physical causal relationship, such as the relationship between pulling a support and moving an object that rests on it, or the relationship between the position of a trap and the safety of a reward placed near it. Gorillas that are tested on these apparatus tasks show patterns of performance that are consistent with causal reasoning in some conditions and with associative learning in others, and the specific conditions that distinguish the two patterns illuminate what the gorilla's causal reasoning system is sensitive to and what it misses. The picture that emerges is of a cognitive system that has genuine causal reasoning capability in the domains most relevant to the gorilla's natural problem-solving context, while showing limitations in the domains where the natural context does not select for the specific type of causal reasoning that the experimental task requires. The attentional behavior of gorillas, which has been studied through the analysis of gaze behavior in both wild and captive populations, reveals the specific social and environmental priorities that the gorilla's cognitive system maintains continuously. Gorillas spend a substantial fraction of their active time monitoring the social behavior of other group members, tracking who is interacting with whom, what the valence of those interactions is, and what the implications are for the current social landscape of the group. This social monitoring is not simply curiosity. It is the ongoing maintenance of the social model that the gorilla's position in the group depends on, and the specific animals that receive the most monitoring attention are the animals whose behavior is most consequential for the observer's own social situation. The silverback monitors the females and the subadult males with the specific attention of an animal, whose social position depends on the specific relationships between those individuals, and the females monitor the silverback and each other with the specific attention of animals, whose access to resources and safety depends on the specific dynamics between them. The specific cognitive demands of nest construction, which is one of the most regular and most observable behavioral expressions of gorilla planning capability, have been analyzed in ways that illuminate the spatial and temporal reasoning that the behavior requires. Each evening, in each location where the group decides to rest, each adult gorilla and most of the older juveniles construct a fresh sleeping nest from the vegetation immediately available. The selection of the specific vegetation for the nest, which varies with what is available, and with the specific requirements of the resting location, involves assessment of the physical properties of the available materials, the structural requirements of the nest, and the specific location's suitability for a night rest. The speed and the efficiency with which experienced adult gorillas construct their nests, compared to the slower and less structurally adequate nests that younger animals produce, reflects the accumulation of experience and the specific learned knowledge of material properties and construction technique that the extended juvenile period of great ape development allows. The grief-like responses that gorilla populations in both wild and captive settings show following the deaths of group members are among the most discussed and most emotionally significant behavioral findings in the gorilla literature. The wild population data from the Virunga research program includes accounts of gorilla groups spending extended time near the body of a deceased group member, of mothers carrying deceased infants for periods of days or weeks, and of behavioral changes in specific individuals that persist across weeks or months following the loss of a close social partner. The captive data includes the specific well-documented responses of individual gorillas, including Coco, to the deaths of animals and humans with whom they had established close relationships. The consistency of these responses across wild and captive populations and across multiple research programs argues against treating them as the idiosyncratic responses of specific individuals and toward treating them as expressions of a general gorilla behavioral tendency that has functional analogues to what the research on grief in humans has identified as the characteristic features of the grief response. The play behavior of juvenile gorillas, which is one of the most visually engaging and most easily observed behavioral expressions of gorilla cognitive and social development, illuminates the developmental function of the extended juvenile period that great ape species share. The specific forms of play that juvenile gorillas engage in, including the chase and tumble play that involves rapid physical interaction between individuals, the object play that involves manipulation and exploration of the physical properties of objects and vegetation, and the social play with adults that involves the specific interactions between juveniles and the silverback that the habituated group observation context makes visible, are all forms of play that engage the developing cognitive and motor systems in the specific ways that prepare the juvenile for the demands of adult life. The silverback's tolerance of juvenile play behavior, including the specific behaviors that would be interpreted as challenges in an adult context, but that the silverback reads correctly as juvenile play, is itself evidence of the social cognitive sophistication that distinguishes adult gorilla behavior from the simpler stimulus response account that the early behavioral research proposed. The research on gorilla welfare in captive settings, which has been informed by the behavioral and cognitive findings described throughout this video, has produced substantial improvements in the housing and management of gorillas in zoos and sanctuaries. The recognition that gorillas have complex social needs, genuine long-term social relationships, individual personalities that differ in their requirements for social interaction and environmental complexity, and cognitive capabilities that require environmental enrichment to be adequately expressed, has driven the development of housing and management practices that are substantially better than those that prevailed before the cognitive research made these requirements visible. The gorilla in a well-designed modern zoo habitat is in a different situation from the gorilla in the barren concrete enclosures that were standard before the behavioral and cognitive research reshaped the field of zoo animal welfare. The research is directly applicable, and the application has genuinely improved the lives of the individual gorillas it has reached. The understanding of gorilla intelligence that the 60 years of research has produced is an understanding that is still incomplete in specific and acknowledged ways. The gorilla is the least studied of the great apes in the laboratory cognitive research, partly because of the specific challenges of working with a species that is physically imposing in ways that affect the logistics of cognitive testing, and partly because the earlier mirror test findings of inconsistent performance led some researchers to discount the gorilla's cognitive sophistication prematurely. The ongoing research, including the field research at the long-term study sites and the captive research at the facilities that house gorilla populations, is continuing to fill in the gaps and to revise the picture in ways that consistently move in the direction of greater rather than lesser sophistication. The gorilla that the next generation of researchers will study will be understood in more detail and more accurately than the gorilla that the current generation has described, and the current generation's work will have made that future understanding possible. The specific finding from the research on gorilla theory of mind, which examines whether gorillas understand that other individuals have mental states that differ from their own, has produced results that are consistent with a limited but genuine theory of mind capability in gorillas. The experimental paradigm that has been most productive in the gorilla research on this question involves competitive food access scenarios similar to those used in the chimpanzee research, where a subordinate gorilla's ability to access food that the dominant cannot see is used to probe whether the subordinate has a model of what the dominant can and cannot see. Gorillas tested on these tasks show behavioral patterns consistent with understanding the dominant's visual perspective, seeking food in locations hidden from the dominant rather than in locations visible to the dominant. This behavior requires, at minimum, a model of the dominant's visual perspective, which is a component of theory of mind that the competitive social context of gorilla life would strongly select for. The relationship between the gorilla's cognitive capabilities and the specific ecological and social challenges of its life illuminates why the gorilla's intelligence has the specific profile it has. The mountain gorilla in the Virunga volcanoes is navigating a seasonal landscape whose food resource distribution changes across months and years. A social group whose dynamics are shaped by the specific relationships between specific individuals with specific histories, a competitive environment organized around the display and the combat system that this channel's previous gorilla video described, and the specific cognitive demands of the nest construction, the infant care, the social relationship maintenance, and the continuous environmental monitoring that daily life in this specific place requires. The intelligence that evolution has built for this specific set of demands is the intelligence that the research has documented. Social, spatial, temporal, and physical world understanding, deployed in the specific integrated way that the challenges of the mountain gorilla's life require. The longitudinal data on individual gorilla cognitive development, which the long-term research programs at habituated gorilla sites have produced by following specific individuals from infancy through the full adult lifespan, is one of the most valuable data sets in great ape cognitive research for what it reveals about how the gorilla's cognitive capabilities develop over time and how they are shaped by the specific experiences of the individual. The juvenile who grows up with a high-ranking mother has a different developmental trajectory from the juvenile who grows up with a low-ranking mother, not because of differences in the genetic endowment, but because of differences in the social resources and the social experiences that the mother's rank makes available. The young male who grows up in a group with a strong silverback has different competitive socialization experiences than the young male who grows up in a less stable social context. These experiential differences shape the specific cognitive profiles of the adult individuals that the long-term research follows, in ways that make the individual variation in cognitive style and behavioral personality that the research has documented not simply random noise, but the specific developmental product of specific developmental histories in specific social contexts. The specific ways in which gorilla intelligence differs from human intelligence, which are as informative about the nature of intelligence as the ways in which they are similar, illuminate the specific evolutionary pressures that shaped each species' cognitive architecture. The human cognitive system's specific strength in the domain of language and abstract reasoning, which allows the construction and communication of complex representations of things that are not immediately present in the environment, is a capability that the gorilla's cognitive system does not possess in the same form. The gorilla's cognitive system's specific strength in the domain of long-term social relationship tracking and the specific spatial knowledge of a familiar landscape, which allows the gorilla to navigate the complex social and ecological demands of its life with a precision that does not require the abstract reasoning that human navigation of equivalent complexity would deploy, is a capability whose expression in the behavioral data illuminates what non-linguistic, non-abstractly reasoning intelligence looks like when it is genuinely sophisticated. The answer to the question this video posed, what would happen if you could read a gorilla's mind, is an answer that the research has built toward, but that the state of the science does not yet allow to be given in the complete and specific form that the question deserves. What would happen is that you would find something genuinely complex, a running social model of the group and its individuals, a spatial model of the familiar landscape and its seasonal patterns, a temporal model of the past interactions and their outcomes that informs the current social assessment, and a specific current assessment of the immediate situation, including you. You would find individual variation, personality differences that have been stable across the years you have followed this specific animal, and memories of specific events and specific individuals that reach back across the years of the animal's experience. You would find something that is not human intelligence, but that is genuinely sophisticated, genuinely specific, and genuinely interesting in the specific way that the research has spent 60 years working to make visible. What you would not find is everything you wanted to find, because the science is still building the tools to see more clearly, and the complete account of what is behind those eyes is still in the future. Sleep well. The specific role of the gorilla's large brain in supporting the cognitive capabilities that the research has documented is a dimension of the gorilla cognition question that the neurobiological research has begun to address. The gorilla brain is substantially larger than the brains of non-great ape primates of comparable body size, and the specific regions of the gorilla brain that are most enlarged relative to the scaled expectation for a primate of the gorilla's body size are the regions associated with social cognition, executive function, and the integration of information from multiple sensory and cognitive systems. The specific neural architecture that supports the gorilla's social intelligence, its problem-solving capability, and its emotional processing is being characterized through post-mortem neuroanatomical research and through the non-invasive neuroimaging research that is beginning to be applied to great apes in research contexts, where the animals can be studied without anesthesia. The picture that is emerging from this neural research is consistent with the behavioral findings, a brain that is organized to support a specific profile of cognitive capabilities shaped by the specific demands of the gorilla's social and ecological life, the emotional intelligence of the gorilla, which the behavioral research has documented through the specific ways that individual gorillas manage their own emotional states and the emotional states of the individuals around them, is one of the dimensions of gorilla cognition that the laboratory cognitive research has been least successful in capturing. The specific behaviors through which gorillas reduce their own arousal following stressful social events, the ways they provide comfort to distressed companions, and the specific social strategies they use to prevent the escalation of tension within the group are behaviors that require the ability to read the emotional states of others and to produce the specific responses that address those states. These capabilities, which the gorilla behavioral research has documented in both wild and captive populations, are the functional equivalents of the empathy and the emotion regulation capabilities that developmental and social psychology has studied in humans, and their presence in gorillas is consistent with the view that these capabilities have deep evolutionary roots in the primate lineage. The specific research program at the Max Planck Institute for Evolutionary Anthropology that has compared the cognitive profiles of multiple great ape species using identical testing protocols has produced findings on gorillas that illuminate their cognitive profile in the comparative context that reveals most clearly what is shared across the great apes and what is specific to each species. The gorillas tested in this comparative research show a cognitive profile that is similar to the chimpanzee profile on the physical world cognition tasks, and different from the chimpanzee profile on some of the social cognition tasks, in ways that are consistent with the different social architectures of the two species. The gorilla's performance on the tasks that involve learning from a social partner, incorporating information provided by another individual's behavior into the gorilla's own behavioral strategy, is one of the areas where the comparative research has found the most interesting species differences, and the ongoing work in this domain is one of the active frontiers of the gorilla cognition research. The researchers who have devoted their careers to understanding gorilla cognition describe their relationship with the animals they study with a consistency of emotional engagement that reflects the genuine quality of the research relationship that extended observation of sophisticated social animals produces. The gorilla that has been known since infancy and that has been followed through the development of its individual behavioral profile and the formation of its specific social relationships is not simply a research subject. It is an individual whose specific history the researcher knows in detail, whose specific social world the researcher has observed across years, and whose specific cognitive engagement with the challenges of that world the researcher has been trying to understand and document. The relationship between the researcher and the subject is not the relationship between a scientist and a data source. It is the relationship between two cognitive systems that have been in regular close contact over years, each assessing the other, each adjusting its behavior in response to the other's behavior, in a social interaction that is constrained by the research context, but that is genuinely interactive in ways that the simple observer-subject model does not fully capture. The specific moment that this video began with, the silverback's gaze across 15 meters of mountain forest, is a moment that the research has spent 60 years trying to understand, and that the understanding is still building toward. What is behind those eyes is a cognitive system of genuine sophistication, a social world of specific relationships and specific histories, a memory of specific events and specific individuals that reaches across the years of the animal's experience, and a specific assessment of the current situation that includes the observer who is sitting 15 meters away and who is being evaluated with the same cognitive attention that the gorilla directs at everything else in its environment that requires evaluation. The research has made it possible to describe some of what is there in specific and grounded terms. It has also made clear how much remains to be described, how many questions the existing findings open that were not visible before the research addressed the questions that preceded them. The gaze across the forest is an invitation extended by an animal that does not know it is inviting, and that does not know that the invitation has been accepted across decades of research that have produced the most detailed account of the gorilla mind available. The acceptance continues. Sleep well. The biological basis of gorilla individual recognition, which is one of the foundational capabilities that the social intelligence documented throughout this video requires, has been studied through both behavioral and neurobiological research. Gorillas recognize specific individuals by face, by voice, and by the specific combination of behavioral and olfactory cues that distinguish one individual from another in the social environment. The face recognition capability of gorillas has been documented through the analysis of their responses to photographs of familiar and unfamiliar individuals, which show differential responses consistent with recognition of the familiar faces that the analysis of equivalent human face recognition research has identified as indicators of genuine recognition rather than simple perceptual discrimination. The specific neural mechanisms of face recognition in gorillas, which are being characterized through the post-mortem neuroanatomical research, appear to involve the face-selective neural regions that the human neuroscience of face recognition has identified in the human brain, which is consistent with the shared evolutionary history of the face recognition capability across the primate order. The specific ways in which the gorilla's cognitive capabilities have been underestimated in the scientific literature, and the specific research findings that have revised the earlier underestimations, trace a pattern that is recognizable across the history of cognitive research with non-human animals more broadly. The initial underestimation was produced by the theoretical assumptions that preceded the empirical research, assumptions that placed non-human cognitive capabilities at a level that the subsequent research consistently revised upward. The revisions were produced by the combination of better experimental design, more sophisticated behavioral analysis, and the accumulation of longitudinal field data that revealed the complexity of individual behavioral profiles across time. Each revision was resisted by the scientific community before it was accepted, and each accepted revision changed the theoretical baseline from which the next round of research departed. The gorilla's cognitive profile has been through multiple rounds of this revision process, and the current understanding is substantially different from and more generous than the understanding that prevailed when the long-term research programs began. The night nests that gorillas build each evening, which this video mentioned in passing, are in many ways the most intimate expression of gorilla intelligence available to routine observation. Each nest is a fresh construction, built in the specific location where the group has decided to rest, from the specific vegetation that the location offers. The nest reflects the builder's knowledge of the local vegetation and its structural properties, the assessment of the specific location's suitability for a night rest, and the specific motor skill that years of nest construction experience has developed. An experienced adult gorilla builds a nest quickly and well. A juvenile gorilla builds a nest slowly and less well, and the improvement of nest construction skill across the juvenile period is part of the behavioral development that the long-term observation data traces in specific individuals. The nest is modest, functional, and ephemeral, and it is, in its own way, a monument to the specific kind of intelligence that the mountain gorilla has developed. Not the language and the abstract reasoning of the human, not the political coalition building of the chimpanzee, but the specific, practical, spatially sophisticated intelligence of an animal that knows its forest in the specific detail that living in it across a lifetime produces. The specific question of what the gorilla is experiencing when it sits and looks at the researcher across 15 meters of mountain forest is a question that the research has made it possible to approach more closely than before, without yet resolving it. What the research has established is that the cognitive system behind that gaze is a sophisticated one, capable of social modeling, spatial reasoning, temporal planning, individual recognition, emotional response, and the specific behavioral flexibility that the dynamic challenges of the gorilla's social and ecological life require. What remains to be established is the subjective quality of the experience, whether there is something it is like to be the gorilla in that moment, whether the cognitive processes running behind those eyes are accompanied by anything analogous to the inner experience that the human on the other side of the 15 meters has. The research is building toward that question with the tools that neuroscience and cognitive science are developing, and the answer, when it arrives, will be one of the most significant findings in the science of mind that the 21st century produces. The gorilla's gaze across the forest is a question that has been asked by every researcher who has sat in the mountain forest with a habituated group and looked into the eyes of an animal that looked back with the specific quality of attention that the accounts consistently describe. The question is not answered by the research that has accumulated in response to it. The research has made the question more specific, has replaced the vague intuition that something is there with a detailed account of some of what is there, and has identified the specific dimensions of the question that remain open and the specific tools that will be required to address them. That is what science does. It makes questions more specific, more answerable, and more interesting. The gorilla's gaze has been one of the most productive questions in the behavioral sciences across the last 60 years. The research it has generated has produced the account that this video has tried to convey. The question it has opened are the questions that the next 60 years of research will address. Sleep well. The animal that looked at you from 15 meters away is the same animal that will build its nest tonight, that will wake in the morning and produce the vocalization that announces the group's readiness to move, that will spend the day navigating the social and foraging demands of its life with the specific cognitive tools that its evolutionary history has built. The research that has spent 60 years trying to understand those tools has produced an account that is more detailed, more nuanced, and more respectful of what the animal actually is than anything that preceded it. What comes next, in the research and in the understanding it produces, will be more detailed still. The gorilla in the forest is not waiting for that understanding. It is doing what it has always done in the forest that made it, with the mind that the forest required. The understanding is ours. The animal belongs to itself. Sleep well. The comparison between the gorilla's cognitive profile and the cognitive profiles of the other great apes that this channel has examined in detail illuminates what is distinctive about the gorilla and what it shares with its closest relatives. The chimpanzee's political intelligence, documented in Frans de Waal's long-term research at Arnhem Zoo and in the field research at Gombe and Thai Forest, is an intelligence organized around the management of large, politically complex communities, where coalition membership determines access to resources and reproductive success. The bonobo's social intelligence, documented at Wamba and Louis Kotale, is organized around the female coalition system and the specific socio-sexual behaviors that build and maintain it. The orangutan's ecological intelligence, documented in Borneo and Sumatra, is organized around the individual tracking of a complex forest landscape and the management of the competitive relationships between widely spaced individuals. And the gorilla's intelligence, documented at Karisoke and in the Bwindi and Virunga populations, is organized around the management of a small, stable social group with deep, long-term relationships and the specific competitive system of male-male display and combat that shapes the group's leadership. Each of these is a genuine form of intelligence, shaped by the specific demands of the specific life each species leads. None is simply a less developed version of the human form. All are specific, sophisticated, and worthy of the attention that the research has devoted to them. The mountain gorilla forest at night holds a kind of intelligence that most of the people who will watch this video will never encounter in person. The research that has made it possible to describe that intelligence in specific and grounded terms is research that took decades to produce. That required the sustained effort of generations of scientists working in difficult conditions, with limited resources, and against the initial resistance of a scientific community that was not prepared for what the field research was finding. The findings that resistance was overcome to produce are the findings this video has tried to convey. They will continue to be built on by the next generation of researchers who will have better tools and a richer theoretical framework and the longitudinal data that the current generation has begun accumulating, and who will produce a more complete account of the gorilla mind than this video can offer. What this video can offer is the current best account, grounded in the research that exists, honest about its limitations, and accurate about what the 60 years of work have so far revealed. Sleep well. The gorilla that sat 15 meters away and looked at you at the beginning of this video has been doing what gorillas have always done across the millions of years of their evolutionary history in this forest: assessing, filing, deciding, living. The mind behind the gaze is not the mind the earlier researchers assumed it was. It is more complex, more specific, and more interesting. The research that revealed this is one of the most significant achievements of the behavioral sciences across the last 60 years, and it continues. The gorilla in the forest is still there, still looking, still the subject of the question that the research has spent 60 years making more specific and more answerable. What would happen if you could read a gorilla's mind is what this video has tried to show. You would find something genuinely worth reading. Sleep well. The specific contribution of the Karisoke Research Center to the understanding of gorilla cognition is worth acknowledging before this video closes, because it is the institutional foundation that the most important gorilla cognitive research has been built on. Founded by Dian Fossey in 1967 in the Virunga volcanoes of Rwanda, and continuing today under the management of the Dian Fossey Gorilla Fund International, the Karisoke program has produced more longitudinal behavioral data on mountain gorillas than any other research program in the world. The specific individuals whose cognitive capabilities and behavioral profiles have been tracked across decades at Karisoke are the data that the scientific understanding of gorilla intelligence is most firmly grounded in. And the researchers who have worked at Karisoke across the decades since Fossey established it have produced the specific findings that this video has tried to synthesize. The Karisoke data, will continue to accumulate. The gorillas, whose cognitive lives it documents, will continue to be born and grow and make their specific decisions in the specific forest where the research was begun. And the understanding of what the gorilla mind is, built one field season and one paper, and one revised conclusion at a time, will continue to deepen. Sleep well. If this video has added something to your understanding of what the gorilla is, consider sharing it with someone who might not know. The research that produced what this video describes is research conducted in one of the most remarkable places on Earth, on one of the most remarkable animals alive, by people who have devoted their careers to a question worth asking. The question is still open, the research is still running, and the gorilla in the forest is still there, still looking, still the most interesting subject in the study of what minds can be and what forms they can take. Sleep well. Sleep. In 2002, scientists studying a forest in Gabon noticed something unusual. The trees were changing, not in the way trees change with seasons. The specific composition of the forest was shifting in ways that the researchers could measure, but that took years to understand. The change was connected to a collapse in the local gorilla population caused by an Ebola outbreak. The gorillas were gone, and without them, the forest was becoming something different. This video is about what the gorilla does to the forest simply by being alive in it. What it moves, what it breaks, what it plants, without knowing it is planting anything. And what happens to the forest when the gorillas are no longer there to do those things. Help us reach 1,000 subscribers. Hit that button right now. It costs you nothing, it takes 2 seconds, and it keeps this channel going. Subscribe now, then stay with us, because what gorillas do to forests is one of the least understood and most important stories in the ecology of Central Africa. The gorilla is not simply an animal that lives in the forest. It is an animal that makes the forest what it is. The distinction matters because it changes what the gorilla's decline means. A species that lives in a forest and then disappears leaves a habitat that continues to function as before. A species that makes the forest what it is and then disappears leaves a habitat that is changed in ways that reach far beyond the disappearance of the species itself. The gorilla's role in the forest begins with what it eats and what it does not fully digest. Adult gorillas consume enormous quantities of plant material daily, up to 30 kilograms of leaves, stems, fruits, and bark, depending on the season and the habitat. A significant portion of the fruit that gorillas consume is swallowed whole or in large pieces with the seeds intact and passes through the digestive system in a condition that allows germination. The gorilla then deposits these seeds in its dung at whatever location the animal has moved to in the hours since it ate the fruit. A gorilla that eats fruit in the morning and moves 3 kilometers by afternoon has transported the seeds of that morning's fruit 3 kilometers from the parent tree before depositing them in a ready-made fertilizer package in a new location. The specific seeds that gorillas disperse are not the small seeds of wind-dispersed plants or the light seeds of species adapted to other dispersal mechanisms. They are the large seeds of species that produce the large fruits that gorillas preferentially seek out. These large-seeded species are often the same species that require animal dispersal because no other mechanism can move seeds of their size effectively across the landscape. The gorilla is not one of several possible dispersers for these species. In many cases, it is the primary disperser, the specific animal whose behavior maintains the population distribution of these species across the forest. Remove the gorilla, and these species do not simply lose one of many dispersers. They lose the relationship that has maintained their population structure for thousands of years. The scale of gorilla seed dispersal across a forest landscape is one of the most striking findings in the ecological research on gorilla-forest interactions. A single gorilla group of 10 to 15 individuals, ranging across a home territory of several square kilometers, deposits thousands of viable seeds annually across its range. The gorilla populations of Central Africa, estimated at several 100,000 individuals for the western lowland gorilla subspecies, collectively disperse millions of seeds annually across millions of hectares of forest. The spatial pattern of that dispersal is not random. It is shaped by the specific ranging behavior of the gorilla groups, the specific fruit preferences of the gorilla, and the specific locations where the gorilla rests and defecates, which are often in the forest interior rather than at the forest edge. Moving seeds from edge-accessible fruiting trees into the interior, where wind and other dispersal mechanisms do not reach. The germination success of seeds dispersed by gorillas has been studied by comparing the germination rates of seeds extracted from gorilla dung against the germination rates of seeds from the same species that have not passed through a digestive system. The results show that seeds dispersed by gorillas germinate at rates comparable to or sometimes higher than seeds that have not been dispersed, which means that passage through the gorilla's digestive system does not damage the seed's viability. Some studies have found that the scarification of the seed coat that occurs during digestion actually improves germination rates by thinning the coat in ways that make water uptake easier. The gorilla's digestion is not simply a transport mechanism. In some cases, it is an active improvement of the conditions for the seed's establishment. The vegetation modification that gorillas produce through their foraging behavior is a second major pathway through which the gorilla shapes the forest. When a gorilla feeding group moves through the understory, pulling herbs and breaking stems and stripping bark from specific trees, it creates a specific pattern of small-scale disturbance that alters the light environment of the forest floor and the competitive dynamics between plant species in the immediate vicinity. The gaps in the vegetation canopy, produced by gorilla foraging behavior, allow light to reach the forest floor in specific locations, which changes the germination success of light-dependent species in those locations and alters the competitive balance between shade-tolerant and light-dependent plant species. This vegetation modification is not simply damage to the forest. It is a specific form of disturbance whose ecological consequences have been shaped by the co-evolution of the forest plant community and the gorilla over thousands of years of interaction. The sleeping nest construction that this channel's gorilla cognition video described as an expression of gorilla planning capability is also a significant form of vegetation modification at the landscape scale. Each night, each adult gorilla bends and breaks significant quantities of vegetation to construct a fresh nest, and the cumulative effect of this nightly construction across the population produces a measurable impact on the structure of the vegetation in the areas where gorillas regularly rest. The broken branches and bent stems of previous nests create specific microhabitat conditions that influence which plant species can establish and grow in those locations. And the spatial pattern of regular gorilla resting sites across the landscape leaves a specific signature in the vegetation structure that researchers can detect in the forest inventory data from areas with and without active gorilla populations. The dung that gorillas deposit in the forest is itself a nutrient contribution whose ecological significance extends beyond the seeds it contains. Gorilla dung is a concentrated package of organic material and nutrients that represents a significant local enrichment of the soil at the deposition site. In a tropical forest ecosystem where nutrient cycling is tight and most available nutrients are locked up in the living biomass of the forest rather than in the soil, the concentrated nutrient input of gorilla dung at specific locations creates localized hotspots of soil fertility that influence plant growth and community composition in ways that the spatial analysis of forest plant distributions relative to gorilla activity patterns has begun to document. The nutrient cycling function of the gorilla, which moves nutrients from the locations where they are consumed to the locations where they are deposited, is an ecosystem service whose value is difficult to quantify, but whose existence is documented in the ecological research. The Ebola outbreak that struck the gorilla populations of the Lossi region of the Republic of Congo between 2002 and 2004 killed an estimated 90% of the gorillas in the affected area, and provided the natural experiment that the Gabon finding mentioned at the beginning of this video represents a version of. The research that examined the forest in the Lossi region in the years following the outbreak found specific changes in the plant community that were consistent with the removal of the gorilla's ecological functions from the system. The fruiting trees whose seeds the gorillas had been dispersing showed reduced recruitment in the forest interior, with the distribution of seedlings shifting toward the forest edge, where other dispersal mechanisms could reach. The understory vegetation, no longer subject to the regular disturbance of guerrilla foraging, showed changes in its composition that reflected the reduced light penetration resulting from the denser, less disturbed canopy. The forest was not destroyed by the guerrilla's absence. It was changed in specific, measurable, ecologically significant ways that the removal of the guerrilla's functional role from the system produced. The connection between the guerrilla's ecological role and the broader pattern of biodiversity that the Central African forest supports is one that the research has approached through the analysis of the relationships between guerrilla habitat use and the distribution of other species in the same forests. The areas of forest that receive the heaviest guerrilla use, as measured by nest density, dung density, and foraging sign, support different assemblages of plant and animal species from the areas with lower guerrilla use, in ways that reflect the specific ecological modifications that guerrilla presence produces. The light environment modifications from foraging disturbance, the seed deposition from fruit consumption, the nutrient cycling from dung deposition, and the structural modifications from nest construction and travel path creation all combine to produce a specific habitat mosaic that supports a specific assemblage of species that the undisturbed or guerrilla-absent forest does not support in the same form. The concept of the ecosystem engineer, which ecologists use to describe species whose activities modify the physical environment in ways that create habitat for other species, applies to the gorilla in a way that is supported by the ecological research. Beavers are the classic ecosystem engineer example in temperate systems, modifying stream hydrology through dam construction in ways that create wetland habitats for dozens of other species. The gorilla is the forest equivalent, modifying the structure, the composition, and the nutrient distribution of the tropical forest in ways that create and maintain the specific habitat conditions that the forest's full biodiversity depends on. The gorilla is not simply one species among many in the Central African forest. It is one of the species that makes the forest what it is for many of the others. The conservation implications of the gorilla's ecological role are profound and extend beyond the welfare of the gorilla species itself to the broader project of maintaining functional tropical forest ecosystems in Central Africa. The Central African forest, which is the second largest tropical forest block on Earth after the Amazon, represents one of the most important carbon sinks in the global carbon cycle, one of the most diverse terrestrial ecosystems on the planet, and the water catchment that sustains the agricultural systems and the human communities of a large region of the African continent. The gorilla is one of the ecological actors that maintains this forest in its current state, and the degradation of gorilla populations through hunting, disease, and habitat loss is therefore not simply a conservation problem for the gorilla species. It is a conservation problem for the forest and for everything the forest provides. The specific threat of commercial bushmeat hunting to the gorilla's ecological function is one that the conservation literature has emphasized in ways that connect the welfare dimension of the issue to the ecological function dimension. Commercial bushmeat hunting in Central Africa, which supplies urban markets with wild animal protein in quantities that the agricultural system does not yet provide, targets large mammals preferentially, and the gorilla is among the species most affected. The gorilla's large body size makes it an attractive bushmeat target, and its relatively slow reproductive rate means that population recovery from hunting pressure is slow. A gorilla population that has been reduced by hunting is a population that is providing less seed dispersal, less vegetation modification, less nutrient cycling, and less of the other ecological functions described throughout this video, and the forest that the hunting has functionally degraded is a forest that is moving toward a different and less diverse ecological state, even if the trees that remain look similar from the outside. The specific research programs that are documenting the gorilla's ecological role in the forests of Central Africa are research programs that combine the behavioral observation methods of the primatology tradition with the ecological sampling methods of forest ecology and the remote sensing methods of landscape ecology. The integration of these methods is producing a picture of the gorilla's ecological function that is more complete and more quantitative than anything the previous generation of research produced, And the picture that is emerging is one that makes the case for gorilla conservation in ecological terms that the species-focused conservation argument alone does not provide. The gorilla is worth protecting, not only because it is a remarkable animal in its own right, which it is, but because the functional role it plays in the forest makes the forest worth less without it, in specific, measurable, ecologically consequential ways. The forest that the gorilla makes is not the forest that would exist in the gorilla's absence. The difference is not dramatic in the short term. The trees that the gorillas dispersed are still growing. The structural modifications from previous generations of gorillas are still visible in the forest's composition. The ecological legacy of the gorilla's presence persists for decades after the gorilla's disappearance from any given area, in the same way that the ecological legacy of a removed beaver population persists for decades in the landscape the beaver shaped. But the legacy fades as the trees seeded by the gorilla mature and die without replacement, as the vegetation structure reverts toward the ungrazed state, as the nutrient cycling shifts toward the pattern of a forest without a large frugivorous primate moving nutrients around the landscape. The forest a century after the gorilla's removal is different from the forest a decade after, and different again from the forest that existed when the gorillas were present. The difference accumulates slowly enough that it is not visible to the observer who sees the forest at a single point in time. It is visible to the ecologist who tracks the forest across the decades of change that the gorilla's absence is producing. Tonight, in the Central African forest, the gorillas that remain are doing what gorillas do: eating, ranging, sleeping in the nests they have built, dispersing the seeds of the fruits they consumed earlier in the day to locations where those seeds will germinate in the months following the gorilla's deposit of them. They do not know they are maintaining the forest. They are simply living, and the living produces the maintenance as a byproduct. The forest that their living maintains is the forest that the research this video has described has begun to document and to quantify. The value of that forest is not captured in any number, but the research has made it more visible, more specific, and more clearly connected to the specific ecological role of the specific animal that makes it what it is. The gorilla in the forest is doing its job. Whether the world that surrounds the forest allows it to continue doing that job is a question that the research has made more urgent and more specific than it was before the ecological findings described in this video were produced. Sleep well. The carbon storage dimension of the gorilla's ecological function adds a layer to the conservation argument that connects the gorilla's fate to global climate dynamics in a way that the species-centered conservation framing does not. The trees that the gorilla disperses, and whose population structure the gorilla's seed dispersal function maintains, are trees that store carbon in their wood across their lifetimes. Large seeded tree species, which are among the most dependent on animal dispersal and among the species most likely to decline without the gorilla's dispersal function, are in many cases also the tree species with the largest wood density and the greatest carbon storage per unit of tree volume. The loss of the gorilla's seed dispersal function from the forest is therefore not simply a biodiversity loss in the narrow sense. It is a potential shift in the tree community composition of the forest towards smaller seeded, lower wood density species that store less carbon, which would reduce the carbon storage capacity of the forest in ways that have consequences for the global carbon cycle. The specific mechanism through which gorilla foraging behavior maintains habitat heterogeneity in the forest, which is the variation in habitat structure across the forest landscape that supports the diversity of species that depend on different habitat conditions, is one of the more subtle but more ecologically significant aspects of the gorilla's ecological role. A forest without the gorilla's foraging disturbance would tend toward a more uniform canopy structure, with the shade-tolerant species that dominate undisturbed forest successional dynamics becoming more dominant, and the light-dependent species that require the specific gap conditions that gorilla foraging creates becoming less common. The diversity of the forest plant community across the spatial extent of the gorilla's range reflects the heterogeneity that the gorilla's foraging behavior maintains, and the reduction in that heterogeneity that would follow from the gorilla's removal would reduce the diversity of the plant community in ways that would cascade through the food webs that depend on the plant community's specific composition. The relationship between gorilla population density and forest health, which the comparison of high-density and low-density gorilla areas within the same forest type has begun to reveal, provides some of the most direct evidence available for the gorilla's ecological function. The specific metrics of forest health that differ between high-density and low-density gorilla areas, including seedling diversity, the density of large seeded tree species, and the structural heterogeneity of the understory, are the metrics that the ecological theory of gorilla function would predict would differ if the function is real and significant. The research comparing these metrics across areas of different gorilla density is still in the early stages, and the findings so far are consistent with the theory without yet providing the comprehensive quantitative picture that would allow the magnitude of the gorilla's function to be precisely estimated. But the direction of the findings is consistent across the available data, and the research program is building toward the comprehensive picture that the conservation applications require. The specific Congo Basin forest, which covers approximately 3 million square kilometers across 6 countries and which is the primary range of the gorilla, is a forest system whose biodiversity and carbon storage make it one of the most ecologically important land areas on Earth. The gorilla's range within this forest, which is distributed across the western, central and eastern portions of the basin in the different subspecies ranges, positions the gorilla as an ecological actor across a substantial fraction of one of the most important forest systems on the planet. The research on gorilla ecology is therefore not research on a local or regional ecological system. It is research on one of the global forest systems that the international conservation and climate communities have identified as priorities for protection, and the gorilla's role in that system is part of what makes the system function as it does. The human communities that share the Congo Basin forest with the gorilla have their own complex and long-standing relationship with the ecological services that the forest provides, and the gorilla's contribution to those services is embedded in this broader context. The communities that depend on the forest for wild food, for water regulation, for timber, and for the specific non-timber forest products that their livelihoods depend on, are communities that benefit from the gorilla's ecological function indirectly through the services that the functional forest provides. The conservation argument for the gorilla that is built on ecological function rather than on species-specific value is therefore also a human welfare argument, connecting the fate of a large charismatic primate to the livelihoods and the food security of the human communities whose well-being the forest sustains. The specific disease events that have reduced gorilla populations, including the Ebola outbreaks of the 2000s and the respiratory disease outbreaks that have affected habituated gorilla groups in Uganda and Rwanda, provide the most dramatic demonstrations available of what the sudden removal of gorilla ecological function from a system produces. The research on the forest changes following these disease events is ongoing, and the findings from the lossy and similar post-Ebola forest areas are the most direct available evidence for the gorilla's ecological role. The specific forest changes documented in these areas, the shifts in seedling composition, the changes in understory structure, the altered nutrient distribution in the forest soils are not catastrophic in the short term. They are subtle, specific, and ecologically significant in ways that the long-term trajectory of the affected forests will make clearer as the research monitoring these areas accumulates more years of data. The palm oil and logging industries that are driving the conversion of Central African forest to agricultural and timberland are the primary forces responsible for the gorilla's habitat loss. And the ecological consequences of this habitat loss extend beyond the loss of gorilla habitat in the narrow sense to the broader loss of the forest ecosystem services that the gorilla's presence in that habitat provides. A forest fragment that is too small to support a viable gorilla population is a forest fragment that has lost the gorilla's ecological function, regardless of whether the fragment itself still contains the trees and the plant community that the gorilla previously inhabited. The minimum area required to support a viable gorilla population is substantially larger than the minimum area required to maintain the physical structure of the forest, and the conservation target that would preserve the gorilla's ecological function requires protecting areas large enough to support viable gorilla populations rather than simply protecting any remaining forest fragment. The reintroduction programs that have been developed for other large mammal species, whose ecological function has been lost from specific ecosystems, including wolf reintroduction programs in North America and Europe, provide models for thinking about the potential for gorilla reintroduction in areas from which they have been removed. The wolf reintroduction research has documented the specific ecological changes that followed the return of wolves to Yellowstone National Park, changes in the behavior and the distribution of elk that produced cascading effects on vegetation, stream hydrology, and the composition of the animal community in ways that the ecologists who predicted them describe as trophic cascades. The gorilla reintroduction research is less developed, partly because the gorilla's reproductive rate and the complexity of its social system make reintroduction more technically challenging than wolf reintroduction, and partly because the habitat areas from which gorillas have been removed are typically also areas where the human pressures that removed them have not been resolved. But the conceptual framework of the trophic cascade, applied to the gorilla's role as a seed disperser and vegetation modifier, suggests that the return of gorillas to areas from which they have been removed would produce ecological changes that the current forest without gorillas would not produce on its own. The specific research methodology that has been most productive for documenting the gorilla's seed dispersal function combines the dung analysis that reveals which seeds the gorilla is dispersing with the seedling tracking that follows the fate of those seeds in the forest. The dung analysis involves collecting gorilla dung samples, extracting the seeds they contain, identifying the plant species from which the seeds come, and assessing the viability of the seeds through germination trials. The seedling tracking involves marking specific seedlings that have germinated from gorilla-dispersed seeds and following their survival and growth over months and years. The combination of these methods produces a data set that connects the gorilla's eating behavior to the specific demographic outcomes of the plant species it is dispersing, allowing the research to quantify the contribution of the gorilla's seed dispersal function to the population dynamics of specific plant species in the forest. The comparison between the seed dispersal function of the gorilla and the seed dispersal function of the other large mammals and birds that share the Central African forest illuminates what would and would not be maintained if the gorilla were removed, but the other dispersers remained. Some of the plant species that the gorilla disperses are also dispersed by forest elephants, by chimpanzees, by large frugivorous birds, and by other fruit-eating animals. For these species, the loss of the gorilla from the system would reduce dispersal intensity without eliminating it entirely, and the population structure of the plant species might recover partially through the continued dispersal by the remaining animals. For the plant species whose seeds are primarily or exclusively dispersed by the gorilla, which are typically the largest seeded species that only the gorilla's digestive system can accommodate whole, the loss of the gorilla from the system would effectively eliminate dispersal, with consequences for these species' population dynamics that the other remaining dispersers cannot compensate for. The specific role of the gorilla as a prey species in the Central African food web, which connects the gorilla's ecological function to the ecology of the predators that have historically hunted it, adds another dimension to the gorilla disappearance question. The leopard, which is the primary natural predator of gorillas in most of their range, has historically included juvenile gorillas in its diet, and the removal of the gorilla from an area that still contains leopards would affect the leopard's prey base and potentially the leopard's own population dynamics. The cascade of effects through the predator-prey relationships of the forest ecosystem is one of the least studied aspects of the gorilla's ecological role, partly because the direct interaction between gorillas and leopards is rarely observed, and partly because the population dynamics of the leopard in the absence of the gorilla are difficult to study without long-term data from areas where the gorilla's removal can be controlled and monitored. But the theoretical framework of trophic ecology suggests that the removal of any major prey species from a predator's diet has consequences for the predator population that cascade through the food web in ways that are not always intuitively obvious from the direct predator-prey relationship alone. The gorilla's role in the forest is most visible in the specific places where gorillas are most active: the fruiting trees where they feed, the sleeping sites where they nest, the travel paths they use repeatedly across the seasons. These hotspots of gorilla activity are locations where the ecological function is most concentrated, where the seed deposition is most dense, where the vegetation modification is most pronounced, and where the nutrient cycling from dung deposition is most intense. The spatial mapping of these hotspots, which the GPS tracking data from collared gorillas and the nest and dung survey data from field researchers have made possible in the last 2 decades, is producing a picture of the gorilla's ecological function that is organized around the specific behavioral ecology of the gorilla rather than simply the average behavior of the species across its range. The ecological function is not uniform across the forest. It is concentrated in the specific locations that the gorilla's behavioral ecology defines, and the conservation of the gorilla's ecological function requires conservation of the specific habitat features that concentrate the gorilla's activity in those locations. The mountain gorilla subspecies, which is the most studied of the gorilla subspecies and the one whose conservation has been most intensively managed, is also the subspecies for which the ecological function question is most complicated by the specific conditions of its range. The mountain gorilla's habitat in the Virunga volcanoes and at Bwindi impenetrable forest is intensively monitored, and the gorilla populations in these areas are growing. But the areas are also surrounded by some of the most densely populated agricultural land in Africa, and the mosaic of forest and farmland that surrounds the gorilla's range means that the gorilla's ecological function is being expressed in a landscape context that is very different from the landscape context in which that function evolved. The seed dispersal that the mountain gorillas provide within the boundaries of the protected forest patches they inhabit is ecological function expressed in a fragment, and the consequences of that function for the long-term maintenance of the forest fragment are different from the consequences of the same function in a continuous, intact forest landscape. The question that the title of this video asks, "What would happen if gorillas disappeared tomorrow?" has been approached across this video's runtime from the ecological direction rather than the conservation direction, building the case for gorilla conservation from the functional role of the species in the ecosystem rather than from the species-centered framing that most conservation advocacy employs. The ecological case is more complex and more difficult to communicate than the species-centered case, because it requires understanding functional relationships between species that are less visible than the species themselves, and because the consequences of losing an ecological function unfold across decades rather than being immediately apparent. But the ecological case is also more durable because it connects the gorilla's conservation to the conservation of the ecosystem services that the forest provides to the human communities that depend on it, and to the global climate system that the forest regulates. The gorilla is worth saving because it is a remarkable animal. It is also worth saving because the forest without the gorilla is a different and functionally diminished forest, and the full ecological and human cost of that diminishment is one of the things that the conservation community is working to make visible, before the gorilla's disappearance makes it visible by default. The specific research findings that have been most important for building the ecological case for gorilla conservation, including the post-Ebola forest studies, the seed dispersal germination research, and the habitat heterogeneity analyses, have been produced by a research community that spans ecology, primatology, plant biology, and remote sensing. The integration of these disciplines in the service of understanding a single species' ecological role is itself a methodological achievement, and the cross-disciplinary collaboration that it requires is one of the reasons that the ecological research on gorillas has advanced more slowly than the behavioral and cognitive research. The behavioral research can be conducted by a team of field biologists at a single study site. The ecological research requires the combination of field biology, plant ecology, and landscape-scale remote sensing data that multiple disciplinary teams working in coordination can provide. The infrastructure for this kind of cross-disciplinary research on gorilla ecology is still being built, and the findings that it will produce in the next decade will substantially deepen the picture that this video has presented. The slow-motion nature of the ecological consequences of gorilla population decline is one of the most significant communication challenges in the gorilla conservation space. The loss of a gorilla is immediately visible. One fewer animal in the count, one fewer individual in the social group. The loss of the ecological function that the gorilla provided is not immediately visible. The seeds that it would have dispersed are not moved to the locations where they would have germinated. The vegetation structure that it would have modified is not modified. The nutrients that it would have cycled are not cycled. The consequences of these absences accumulate over the years and decades that follow the gorilla's removal, becoming visible only to the researcher who is tracking the forest's composition across time. The slow accumulation of consequence is real and significant. The communication challenge is making it visible in the compressed timeframes that policy decisions and conservation advocacy require. The argument for gorilla conservation that the ecological research provides is ultimately an argument about what kind of forest Central Africa will have in 100 years. A forest with gorillas will be a forest whose composition and function reflects the gorilla's ecological role in shaping it across the decades and centuries of the gorilla's continued presence. A forest without gorillas will be a forest that is moving, slowly, toward a different composition and a different function, as the ecological consequences of the gorilla's absence accumulate across the decades following its removal. The two forests are both still forests. They are not the same forest, and the difference between them in carbon storage, in biodiversity, in the specific ecological services that each provides to the human communities and the global climate system that depend on them, is the difference that the gorilla's presence or absence makes. This video has tried to make that difference visible. The gorilla in the forest tonight is making it real. Sleep well. The specific communities of plants and animals that depend on the ecological conditions that the gorilla creates and maintains are communities whose conservation is embedded in the conservation of the gorilla, whether the conservation community explicitly recognizes this or not. The large-seeded tree species, whose population structure depends on gorilla dispersal. The specific understory plants that depend on the light conditions that gorilla foraging disturbance creates. The insects and the birds and the small mammals that depend on the specific habitat mosaic that gorilla activity maintains are all species whose conservation is implicit in the conservation of the gorilla and explicit in the conservation of the gorilla's ecological function. The gorilla is not just one of many species in the Central African forest. It is one of the species that makes the forest what it is for many of the others, and the conservation of the gorilla's ecological function is the conservation of a substantial fraction of the biodiversity that the Central African forest supports. The answer to the question this video posed, what would happen if gorillas disappeared tomorrow, is an answer that plays out across different timescales. Tomorrow, what would be visible is the absence of the gorilla. In a decade, what would be visible is the reduced recruitment of large-seeded tree species in the forest interior. In a century, what would be visible is a forest whose composition has shifted towards smaller seeded, less diverse species in the areas that the gorilla previously ranged through, and whose carbon storage and biodiversity values reflect the accumulated decades of the gorilla's ecological absence. The gorilla's ecological role is not dramatic in the way that the gorilla's behavior is dramatic. It is slow, cumulative, and expressed across timescales that require the long view to perceive. But it is real, it is documented, and it is one of the most compelling arguments available for the conservation of an animal that does not need additional arguments for its remarkable qualities, but that benefits from an argument that connects its conservation to the health of the forest system that the rest of the world also has a stake in maintaining. Sleep well. The specific plant species that would be most immediately affected by the gorilla's disappearance from the Central African forest are species that have co-evolved with the gorilla across thousands of years of mutualistic relationship. The fruits that gorillas preferentially consume have evolved specific characteristics that make them attractive to gorillas. Size, flavor, nutritional content, and seed dimensions calibrated to the gorilla's digestive system. These fruit characteristics are not general attractants for all frugivores. They are specific attractants for the gorilla, refined by the co-evolutionary process that selects for plants whose fruits are effectively dispersed, and for dispersers whose preferences and digestive systems are calibrated to the plants they consume. The gorilla and the specific plants it disperses are partners in an ecological relationship that has shaped both partners across the evolutionary history of their interaction. Remove the gorilla, and the partner relationship is broken, and the plant species that evolved in the context of the relationship loses the specific ecological partner whose behavior its evolutionary history has been shaped around. The gorilla's water management function, which has received less research attention than its seed dispersal and vegetation modification functions, but which may be equally significant for the forest's hydrological dynamics, is a dimension of the gorilla's ecological role that the landscape-scale research is beginning to address. The gorilla's foraging behavior in the forest floor vegetation, which includes the consumption and modification of the mosses and the ground-level plants that retain moisture in the forest soil, affects the specific hydrological properties of the forest floor in the areas where gorilla foraging is most intense. The retention of moisture in the forest floor is one of the factors that influences the stream flows and the groundwater dynamics that the agricultural communities surrounding the forest depend on for their water supply, and the gorilla's contribution to this function is embedded in the broader hydrological service that the intact forest provides. The specific magnitude of the gorilla's contribution to the forest's hydrological function is not yet quantified with the precision that the carbon storage and the biodiversity research provides for those services, but the theoretical basis for expecting a significant contribution is present in the specific details of the gorilla's foraging behavior and its effects on the forest floor structure. The specific experience of being in the Central African forest in an area with an active gorilla population versus an area where the gorillas have been removed, which the researchers who have worked in both types of areas describe with a consistency that reflects the genuine perceptual difference between the two environments, adds a human dimension to the ecological argument that the quantitative research cannot capture. The forest with gorillas has a quality of presence that the forest without gorillas does not have, not in the mystical sense, but in the specific ecological sense that an active, large mammal population creates through its sounds, its signs, and the specific modifications it makes to the environment that mark its presence for anyone who knows how to read them. The nest sites, the feeding trails, the dung, the specific places where the vegetation has been modified by gorilla activity are the signs of an active ecological agent that is shaping the forest from the inside. Their absence from a forest that was once occupied by gorillas is itself a kind of sign, and the researchers who read it describe the reading with a specific quality of loss that the scientific language of ecological function does not fully convey. This channel has spent the last several videos documenting what gorillas are, how they fight, how they think, and now what they do to the forest that produced them. The three together are the complete picture, or as complete as the current research allows. The gorilla is a competitor, whose combat system this channel has described. It is a cognitive system, whose intelligence this channel has described, and it is an ecological engineer, whose functional role in the forest this video has described. All three are the same animal, expressed in different behavioral contexts, shaped by the same evolutionary history in the same forest environment. Understanding all three is understanding what the gorilla actually is, rather than what the simplified image of it suggests. That understanding is what this channel is for, and the gorilla has been one of the most rewarding subjects it has addressed. The forest continues. The gorillas in it continue their work. Sleep well. The gorilla's disappearance from a specific area of forest is not an event that produces immediate dramatic change. The trees that the gorilla dispersed are still there. The structural modifications from previous generations of gorillas are still embedded in the forest's composition. The ecological legacy of the gorilla's presence persists for decades in the specific distribution of tree species, in the specific structure of the understory, in the specific nutrient profiles of the soil at the sites where generations of gorillas deposited their dung. The disappearance is quiet, its consequences accumulate slowly, and the forest that emerges from those accumulated consequences over the decades following the gorilla's removal is a forest that is different in ways that the research is working to document before the gorilla's disappearance from more areas makes the comparison between the two states of the forest a historical one rather than a contemporary one. The research is working against the timeline of the gorilla's decline. The race is between documentation and disappearance, and the outcome of the race will determine how much we understand before what we are trying to understand is gone. The gorilla that is in the forest tonight, dispersing seeds and modifying vegetation and cycling nutrients and doing all the other things that its living in the forest produces, does not know it is doing any of these things in the ecological sense. It is eating, ranging, sleeping, surviving. The ecological function is the byproduct of the living, not the purpose of it. The purpose of the gorilla's eating is the gorilla's nutrition. The purpose of the gorilla's ranging is the gorilla's access to the food and the social partners that its life requires. The ecological consequences of the eating and the ranging are not the gorilla's purpose. They are the forest's benefit from the gorilla's living, accumulated across the evolutionary history of their interaction into the specific mutualistic relationships that this video has described. The gorilla needs the forest to live. The forest needs the gorilla to be what it is. The relationship is old, specific, and consequential in both directions. Sleep well. The specific conservation programs that are working to ensure that the gorilla continues to be in the forest, doing what the forest requires it to do, are programs whose work this channel supports by making the case for the gorilla's value as specific and grounded as the research allows. The mountain gorilla program in the Virunga volcanoes and Bwindi. The Western lowland gorilla research in Gabon and the Republic of Congo. The cross-river gorilla conservation effort at the Nigeria-Cameroon border. Each of these programs is working against specific threats in specific places, and each has produced specific conservation outcomes that the research has documented. The mountain gorilla's population growth from below 600 to over 1,000 individuals is the most dramatic of these outcomes, and it is proof that the conservation investment works when it is sustained and well designed. The ecological function that the mountain gorilla provides to the Virunga and Bwindi forests is being maintained and recovered as the population grows, and the forest that these gorillas inhabit is a forest that is getting better rather than worse, one of the few such stories in the conservation of great apes. The other subspecies need the same sustained investment in the same specific conservation approach, and the ecological argument that this video has made is one more reason why that investment is worth making. Help us reach 1,000 subscribers by sharing this video with someone who should know what the gorilla actually does. Sleep well. The forest that exists today in Central Africa is a forest that has been shaped by gorillas for as long as gorillas have been in it, which is millions of years. The specific composition of the tree community, the specific structure of the understory, the specific distribution of nutrients in the soil across the landscape, all of these are the accumulated product of millions of years of gorilla eating and ranging and sleeping in this forest. The forest is the gorilla's ecological legacy, as much as it is the product of the rainfall and the soil and the climate that the physical environment provides. Removing the gorilla from the forest is removing one of the primary forces that has shaped the forest into what it currently is, and the forest that results from the removal is a forest that has lost one of the processes that has been writing its composition and its structure across geological time. The research that documents this process is the research that makes the loss visible before it becomes irreversible. The gorilla in the forest tonight is the process in action. Sleep well. The specific relationship between the gorilla's ecological function and the human communities that share its range is one that the conservation community has been working to make more visible and more valued. The communities that live at the forest edge in Rwanda, Uganda, Gabon, and the Democratic Republic of Congo have relationships with the gorilla that are complex, and that include both the conflicts that arise from crop raiding and the benefits that arise from the forest services the gorilla helps to maintain. The gorilla that ranges into agricultural fields and damages crops is a cost to the community. The gorilla that disperses seeds and maintains forest structure and contributes to the water regulation and the biodiversity that the forest provides, is a benefit to the same community, expressed through the ecological services of the forest rather than through direct interaction. Making the benefit as visible as the cost is one of the communication challenges of the conservation programs working in these communities, and the ecological research described in this video is one of the tools that can make the benefit more specific and more quantifiable.